Today, we're going to go ahead and take a look at a whole bunch of systems of equations. We're going to look at those two equations of the line, and we're going to determine which of the methods that we've worked on so far this chapter is the best method in order to solve, which one will take the least amount of work, which one is the most efficient. So here are our three equations our three systems of equations that we're going to be evaluating. So here's our example one. We have the equation 5x plus 7y equals 2 and negative 2x plus 7y equals 9. So as we're looking at each of these equations, I want you to kind of think through which one do you think is going to be the best. We looked at substitution. We looked at equal values, which is a special type of substitution. We looked at elimination. And of course, we have our fallback from what we learned in middle school, which is finding the solution, which is where those two lines cross, from graphing on a piece of graph paper. So let's look at example number 2 that we're going to be analyzing. We have 2x minus 3y equals negative 12. And our second equation is x equals 5y minus 4. Okay, then we're going to have one more example that we're going to analyze. And this one is y is equal to 1/3 x minus 4. And y equals negative 2/5 x plus 2. So let's go ahead and focus on example number 1. And what do we notice about this system? Well, I notice that my x's are lined up, my y's are lined up, and I have constants on the other side. And of course, we know that this means it's in standard form. So which one of those methods did we learn that works best if we have both equations in standard form? So I want you to think on that. And hopefully you remembered that this will be a great way to use elimination. Now, ideally, the easiest is if we had either our x's or y's opposites of each other. We're pretty close here, though. We have two 7y's. So we're going to go ahead and rewrite one of those by multiplying every single term on both sides by a negative. So we can rewrite that first one, and that's going to be negative 5x minus 7y equals negative 2. At that point, once we've found those opposites, we're going to add them together. We'll then solve for x, plug that back into one of the original equations, and then go ahead and solve for y to get our ordered pair. Now, the reason why elimination works for this is both equations are in standard form. So if you see both equations on standard form, elimination is a good choice for that series. Now, we're going to go ahead and take a look at example 2. We have one equation in standard form, 2x minus 3y equals negative 12, and one equation that's an x equals 5y minus 4. So let's think, which one would this best fit? I hope you're thinking about substitution. Whenever we have one of our equations in x equal or y equal form, we know that we can rewrite the other equation and put what that is equal to in place of that variable. So in this case, x is equal to 5y minus 4. So we're going to rewrite the top equation by going 2, and then where x is, we're going to put parentheses and put what x is equal to, which is 5y minus 4. Close those parentheses, minus 3y equals negative 12. We're then going to go ahead and distribute by multiplying everything by that 2, and then we're going to go ahead and solve for y. After we solve for y, we're going to plug that back into our x equals equation and solve for x. So for this system, substitution is going to be our best technique. Okay, and that's because one equation, or at least one equation, they can both be in this form, is x equal or y equal. So let's go ahead and take a look at that third system. We have y equals 1/3 x minus 4, and y is equal to negative 2/5 x plus 2. Now, both equations are in slope-intercept form, so generally we would say, yeah, let's go ahead and do substitution, and we'll be using that equal values for substitution, y equals y. So we would have 1/3 x minus 4 is equal to negative 2/5 x plus 2. However, for some people, our fraction skills of finding common denominators isn't always the best. So if you're someone who's great at fractions, use substitution equal values. If you're someone who kind of cringes away from fractions, then I would go ahead and default back to what you learned in middle school, which is simply graphing to solve these. So that's the case when they're both in slope-intercept form, and there might be fractions there that are a little bit harder for you to work with. So what you're going to do for that top equation is you're going to graph on the y-intercept the negative 4, And then you're going to move the slope up 1 and 3 to the right, rise over run. Up 1, 3 to the right, and then draw that line that goes all the way through. And then for our second one, we're going to plot our y-intercept on the y at 2, and then we're going to drop down 2, 5 to the right, down 2, 5 to the right. Once those are both graphed nicely using your ruler, you can simply look and observe where those two lines intersect. So ladies and gentlemen, in our Desmos activity today, you're going to first have a slide which simply says which one is best. After you choose which one is the best and why you think so, you're going to go ahead and solve using that system of equations method that you selected. Now, when you're done with all of these, you will need to upload a picture of all of your work in order to get credit for these. So make sure that you are writing the screen number and make sure you're showing all of your work in order to find where these two lines intersect.